Okay, I wanted to give another video, just another example of graphing inequalities. What's different about this is that one inequality is solved, it has the variable by itself, but the other one does not. So let's deal with these one at a time. First, in blue, line 1, we see that x is greater than -1, and you might be saying, hold on, I don't have a y equals, it's not in slope-intercept form, what do I do? Well, what this means, the way I would read this, is that this line, this inequality, is going to go through the x-axis at -1. So remember, here's our x-axis, our horizontal axis, and I'm going to draw a line that cuts through that x-axis where? At -1. Now, before we do that though, so here's -1 on the x-axis, and I'm going to draw a line cutting through that. From our inequality symbol, because it's the greater than symbol and there's no equal to sign, we're going to use a dotted line. So as we cut through the x-axis at -1, I'm going to use a dotted line. Now, which way should we shade? This is a little different than above the line, below the line. X is greater than -1. Well, where are my x values beyond or getting larger than -1? Is that as I move to the right or move to the left? So here's -1 and 0 and 1 and 2 and 3. I'm getting larger or greater as I go to the right. So I'm going to shade all of this area over here to the right, where my x is greater than 1. So that is the first line. Now, the second inequality, we need to solve and put that in the slope-intercept form. So remember, when I do that, I want to move the term that's not attached to the y over to the other side. I want to get y isolated or by itself. So how I do that is to undo a positive 3x, I'm going to subtract 3x. So I'm going to subtract 3x from both sides. Here's where you have to be careful. So we're left with a -3y, and this is less than. These are not like terms, so I cannot combine them. So I want to write my x term first to keep it in slope-intercept form. So I'm going to write my -3x first, and this is a +6 because there's no sign there, so this is +6. My very last step is to get rid of this -3. So because it's being multiplied to y, I'm going to divide all terms on both sides of this inequality by this -3. So I'm left with y. What do I do with this inequality symbol? Because I divided by a negative. If you multiply or divide by a negative, you have to flip the inequality symbol. I hope you were marking in pen because a lot of you may have made that mistake here. So instead of less than, this becomes greater than, and a negative divided by a negative is going to be a positive. So this is a +1x. So that means our slope is 1. We're going to go up 1, right 1. And then a +6 divided by a -3 is a -2. So my y-intercept is going to start at -2. Let's go ahead and graph this inequality for line 2. So I'm going to go down 2 and put my first point. From that point, my directions say that I have a +1 attached to this x as my slope. So +1 meaning I'm going to go up 1, right 1. So up 1, right 1, up 1, right 1. And then also the opposite direction would be down 1, left 1. Here's where they intersect. But now when I connect these, am I going to use a dotted line or a solid line? It's going to be a dotted line because I don't have an equal to symbol here. So I'm going to connect these with a dotted line. And now, which way do I graph? Am I going to graph above this line or below this line? So it's the greater than symbol. So I'm going to shade above the line. And so notice how our line is like this. We're going to shade above it. And we're looking for where does our shading overlap. So I don't have any blue shading over here, so it doesn't overlap yet until I get into this section. See how blue and purple kind of mix together? So our solution is going to be in this region where blue and purple overlap. So this little triangle that is made right here. So to the right of this blue line and above this purple line. Over here I only have purple shading, no blue. Over here I only have blue and no purple. And actually in this little section I don't have either blue or purple. Now let's just talk about a couple things. If we wanted to come up with a coordinate point that made this true, you pick any point in that shaded region. So for example, you could pick the point 3, 8. So let's find it. So 3 meaning I go right 3, up 8, 3, 4, 5, 6, 7, 8. So this 3, 8 would be a solution to both inequalities. What is an example of something that is not a solution. Something that's not a solution would be the point 4 or 3 comma 1. So if I go to the right 3 and up 1, this point right here, 3 comma 1, that is not a solution because why? It is on the dotted line. And because this point falls on the dotted line, that means it can't be equal to that. It would have to be on the line. So it can be really, really, really close to it. If we had 2.999 comma 1, then that would be acceptable. That would be a solution. But because it's 3 comma 1, it can't be equal exactly on that line. So be careful as you are trying to come up with points that are and are not solutions to the system of inequalities.